Hello. Now I'm going to talk about design, which is particularly important in software engineering and engineering in general, and probably even in other activities. And if you look at the page about design, they will talk about on Wikipedia. They will talk about the verb, which is the process of doing design, and the noun, that is the result of this process. And what you realize from these is that basically when you talk about design, talk about a plan or a prototype of the artifact that you are going to develop. And but when you look at design, usually, or when you think about design, you are thinking about something that has good qualities and says in terms usually you refer about elegance. Okay, so what is this elegance actually? And if you realize, most of the times elegance is a relation between structure and function, in the sense that they are really balanced, and and really important, at least in software, but I think in design in general, is that this structure is simple and results from the composition of elements that basically follow the same rules. And when you have some design that you look at it and say, wow, so nice, is because these are with just a very few rules, so you don't have so many different rules. With a couple of rules, you can just build a functional thing. So an artifact that has this functional capability. Okay, so this is an important aspect, and we'll see this is what is difficult when you develop software. And another thing that is interesting is that sometimes you look at design as something that you think upfront, in the sense, well, I need to do the design before the implementation. And when you are implementing, you are not doing design. Actually, you are doing design every moment. So when you decide which are the parts of the things you are building, and when you decide how you are going to connect these parts, you are doing design. Okay, and you can do it in an elegant way with a few elements, or in a not so elegant way with a few elements, with a lot of elements types, a lot of different connections, and that we can get completely lost in the middle of design. So actually, when we have a good design in the sense of elegant, it means that it's more easy that you don't introduce errors when you are implementing according to that design, because the design is so simple that you can really understand what are the parts and what are the relations between parts. A very good definition about design is by Tony Orr. Okay, and Tony Orr has this definition that I think everybody in computer science keeps repeating, that says there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies. And the other way is to make it so complicated that there are no obvious deficiencies. Okay? So I think that is the basic of software in general, not only of design, okay, but is that things should be simple. Okay, so if they are simple, then you can look at them and you can prove or you can test them, but it's easy to verify that they have no errors. So the goal of design, I think, is simplicity. Okay, of course, the simplicity you can have your system, but a good design should go for simplicity. And simplicity is to pick the minimal set of element types necessary to build these artifacts. So by applying these types of components or modules or relations, you can build your product. Okay. Another interesting story. So you have Tony Orr. Okay, that was a computer scientist that has done a lot of contributions for computer science. And you have also Michael Jackson that he contributed to structured programming, and he tells a very in one of its books, it tells a very interesting story about, actually a very insightful story about what is the core of software development, and I think that it's strongly related with design. So it tells a story that was teaching in a company, teaching these structured methods in the 80s. I think it was in the 80s. And during the break, it was called just to the office of the manager, and the manager asked him about what he think about the work of, or the quality or the ability, the competence of one of the people that was doing in the class. That was, I think it was John, and Michael Jackson answered that yes, he looked competent. And then it's just the measure shows that he was the best guy out there. He just built this big model that was in the wall. Yes, and it was so complex that sometimes he was the only guy that could understand it, and sometimes could not even understand it. Okay, so it has some difficulty. So complex it was. And then Michael Jackson asked him about Anne. And the managers answered that Anne, before was hired, had very good references and a very competent professional. But so far, all the problems that they gave her to solve, revealed to be quite simple and quite easy. And I think this is a very interesting story about what is doing software. Okay. It's like a Columbo's egg, right before, after you do it, everybody says, I could do it as well. Okay, so yes, that's a bit the fate of the software engineers, but I think it's important that you know it and understand a bit what is design, what is building software, and why simplicity is difficult and at the same time is not recognized or not easily recognized. And to finish, I want just to present you a little bit about what is the quality of design. So what are the qualities? Or let's look in a different way. What are the problems that design? So let's think that you have a module, this concept of a module. So think, and a module basically is a design entity that is implemented the code that has an interface. So the other modules interact with the modules through its interface. Then you can have different definitions of interface. I will address these, and different qualities of the interface. And we take when you think about a module, you can think in terms of a class in object orientation, but you can think about larger things, like for instance about our quiz module or our question module, admin module, etc. And the point here is, why is it difficult to change code? And the point, if you think, is that the cost of changing 100 modules, one line of code in 100 modules, is much higher than the cost of changing 100 lines of code in a single module. Why? Because humans, the human brain, can basically define a context. And it is very good about thinking and reasoning when you don't change the context. If you keep changing the context, what is going to happen is then human brain, so a computer is better doing this, but human brain is not good about keeping all these different contexts. So if you need to do a change and need to change in a lot of places, well, then it's difficult, okay? And is more error prone, which means that the design is not so good. So what should be the quality? The quality of a good design is that you want basically to restrict the propagation of change. So when you change something, you want to have what is called locality of change. So all the changes should occur inside the same model. And that's what you need to do. So when you design your system, you should follow some rules that allow you that in the future, guarantees you that in the future when changes occur, they follow this locality of change principle, okay? So it means that one of the reasons is that means that internally to the module, all the things that are inside the module are strongly related, okay? And to reduce the propagation of change means that each module should have its own responsibility, so that they just, you only need to change in different modules when you are actually, your change means that you are changing different responsibilities, you are changing different concerns. Okay? And look at this, we talk a lot about encapsulation. You learned a lot about encapsulation. You learn about a lot about interfaces. But that means nothing. Okay? I can have an interface, but if what is relevant, and I will talk about it, an interface is the abstraction is in the interface. So what should be strong, what really encapsulates the implementation is the abstraction. So if actually the interface does not, the interface does not add the implementation, so if the abstraction is poor, it doesn't create something higher level that you can interact with, ignoring the details, then, well, you have a lot of propagation of change. Why? Because basically, when you change something inside the module, it means that the interface, you need to change the interface. And if you need to change the interface, then you need to change other module. Okay, that was the introduction, and now let's go for it.